Hi, my name is Dawson, and this is a parameter and function tutorial for Substance Designer. This tutorial assumes that you have basic working knowledge of Designer, but have never touched the function graph. So I'm going to give a quick overview of what parameters and functions are, and then dive into a few simple examples just to showcase what some of the function nodes do. So to start off, I have this tile sampler loaded up. If I double click on it, it gets the displayed in properties icon, so you know that that's what we're looking at. And everything over here in the Properties tab under Instance Parameters, these are all the parameters. They're essentially just variables of this particular node. So I can click this icon here, which is the function icon, and go to Expose. It'll give a default name, and sometimes these defaults overlap each other, so always make sure that you're using a discrete name if that's important. In this case, I'm just going to pick the default. And now I can no longer use this control here. Instead, I have to double click to the root of the graph, and I have this control here. And when I move this, of course, the node updates. So a simple use case for something like this might be you expose this X and you want to make bricks that have a 2:1 Y to X ratio. So if I go back into this node here, I can go to the Y now. And instead of going to expose, I'm just going to click empty function. There's an expected output type of the graph, which is an integer 1. So if I do get integer, I can grab that X amount. And if I set this to output, you'll see it updates. And now I'm having that same X amount variable apply to both the X and the Y. If I wanted to make it 2:1, I can grab a multiplication node. Then I can grab an integer, keeping the data types between these similar. If I plug these in, change this integer to 2, and then set this as the multiply, or set this multiply as the output. Now I get this 2:1 ratio, and if I go back, anytime I change this, we're always going to keep that ratio between the X and the Y. If I decide to delete this, I can delete it, but that parameter will still be exposed and it will be controlling nothing. So you can keep this and reuse it later if you like, or you can just hit this X to delete it. Now I'd like to make something a little bit more interesting. This is going to be a 4-way directional warp that basically warps an input in 4 cardinal directions. It's a little bit different from the included multi-directional warp in Designer. I like the results a little better. So to start, I've just got this basic setup of an input tile generator, Gaussian noise for the intensity, and then a directional warp set to default. The first thing I'm going to do, expose this intensity value. I'm going to expose the warp angle, and note the name also defaults to intensity. So just be careful with this naming thing. Make sure you switch that. And now I'm going to copy this, paste it, hook those two together, and in this second directional warp, I'm going to go into the warp angle graph by clicking on it, and here I'm going to add an add node, and the output type is float. So in the context of a rotation, 1 will be a 360-degree turn, so I want to rotate a half a turn, or 0.5, 180 degrees. So if I hook these into the add, set this as output node, now we're warping to the left, and then we're warping again to the right. And I'm going to copy and paste that second directional warp again. Go into this function of the third now directional warp. This is going to change to the up direction, 90 degrees or 0.25. Copy and paste this. You can probably see where this is going. Going to go down now, 7.5. And now we have one intensity value that warps all of these warps together. I'd also like to add a control for how many of these are going to be used in sequence in the final output. So to basically be able to turn each one on or off. So to do that, I'm going to create a variable first, or a parameter first, by hitting this little plus icon here over in the global parameters. I'm going to call this directional selection, and I'm going to change the type to integer. I'm going to set the min to 1 and the max to 4, And then I'm going to create a blend node to make use of this. I'm going to put the first directional warp in the background and the second in the foreground. Going to switch the mode to switch so that it only will ever evaluate to a 0 or a 1. Now I'm going to go create an empty function here for this opacity. And basically the way this is going to work is we want to get a get integer to grab that variable directional selection we just created, and then a comparison node. If you type in compare, you start to get all these. You can also type like G for greater or whatever. So I want a greater, and then also this conditional if else. So we're going to plug this greater into the top, the condition here, and then I'm going to plug the directional selection into the A of the comparison. The data type for this, because it's using the opacity parameter of this blend, that's where this function is. It's still going to be a float data type. So this, you'll notice, has a yellow. That means it's an integer. We want to change that to a float first. So type T for to float. And now if I hook these two together, they will behave. And I'm going to set this to 1. So basically, if the value of directional selection is greater than 1, then we're going to set its value to 1. And if not, I'm going to set its value to 0. If I set this as the output node, you can see now I'm previewing this. It's only going one direction. If I go back to the directional selection, move it to 2, now it's incorporating this second one. Now it's going 2 directions. So we're just going to copy and paste these for the additional directional warps. So this one's going to go into that, and then this one is going to go here and here, and each of these needs to be modified slightly. So in this second one, I'm actually going to copy and paste this and set this to, it's still, we always want 1 or 0 to be evaluating here because that's the final output of the opacity. But this now, because it's the second in the chain, it's going to be greater than 2. Now we'll go back to this, and here, same deal. Copy paste that. Let's change this guy to greater than 3 for that final one. So now we have this control that will select how many directions we actually want to include. And if you turn clamp to true, then on the final value, you won't be able to go beyond 4 or beneath 1. And it's this nice little, hopefully intuitive control for that. So the last thing to do to create this utility node is just add an output and then add an input grayscale. I'm going to plug this in here. Going to copy paste this, and if you hold shift you can move all the connections from a node. So going to take these two and copy them. Here I'm back in that original blank graph, and I've got these two testing nodes ready, pasted over. So now I'm just going to go up to the Explorer, drag and drop the 4-way warp graph that we just made, and here we get it as a node. So plug these into the inputs, and you can see now we have that whole graph in one handy little node, and all of its parameters should work properly. So hopefully this gives an idea of how you can speed up your workflow doing something that would normally be really repetitive, like setting up a chain of nodes. If you want to make a utility node out of it, use a couple simple functions. You can do that work once and hopefully never again, right? Next, I'd like to talk about a common issue with tiling nodes and how to create an automated solution using a function. So I have this tile sampler set up, and it's default in every way except the pattern has been set to disk. I'm going to change these to really easy small numbers just to simplify things. Basically, if I have a 2-to-1 ratio with the X to Y tiling, you can see that these are twice as tall as they are wide, and that's just a virtue of how the tiling will stretch when the tiling values are not equal. So the problem is, what if you want these to always be circular? Well, you could go down and you could, every time you have a 2-to-1 ratio here, you could set a 2-to-1 ratio on your size, and that will make them circular, but what if you wanted a general solution so that anytime you changed these, you would always have this size automatically changing? So that's what we're going to set up. The first thing to do is going to be to expose these parameters. So I'm going to expose the X, and then I'm going to expose the Y and mind the name overwriting. I'm going to make sure to change that to Y. Now I'm going to come down here and create an empty function for the size. Let's just set this back to default so we can see the issue clearly. So the first thing to notice about the size function graph is that it's a new data type. It's a float2. So if I type float2, you can see it's just two floats together, and they're independent of each other. So this is basically going to be the output of this graph. If I set them to 1 and 1 and set this as the output, that's where our default is at, and I can change the Y to 0.5, and you can see this is like our solution. So this is basically what we're trying to solve for. I'm going to copy this and set it to 1 and just use this as kind of a placeholder to remind us. But now I'm going to set this to the main output, and I'm going to start by getting an integer for the X and the Y. I'm going to set this with T to a float because we're in a float data type. Copy, paste, and then grab the Y amount. So we have an X and our Y. And again, our first condition is, are these amounts equivalent? Because if they are, then the size value doesn't need to be changed at all. So to do that, we're going to create an equal and hook those up. And then, of course, a conditional statement, if else. So if they're equal, I'm just going to plug in this 1 and 1 that will be unchanged. That's 1 on the X size and 1 on the Y size, top and bottom, right? So that solves for the condition if they're equal. Now we need for if X is bigger than Y and if Y is bigger than X. So we're going to need another conditional, and we're going to hook that into the else. So what we want to do is check which one of these is greater. So I'm going to once again get a greater node and plug them together. So basically we're checking if X is greater than Y, which in this case it is. So if it is, we're going to use this first conditional statement. But again, this needs to be a vector2 or a float2. So I'm going to grab this vector float2, and this needs to take in some value that will evaluate to 0.5 on the Y, and also a 1. So we already have a 1 here. So I'm just going to grab a swizzle, and this basically takes some multiple float value and just isolates one of those values. So both of these are 1. It doesn't really matter which you choose here. There's up to 4 options you can choose from for up to the float4 data type. But I'm just going to grab a 1 from here, and so that's going to be my X. And then for the Y, I want the value of Y divided by X, which would be 0.5. That's the corrective value I'm looking for. So if I grab a division node and I take Y in the top, I divide it by X, I put that in for the float2, I plug that into this condition, I set this as the output, and you can see those correct in size. So that solves for X being greater than Y. Now we need the condition for Y being greater than X. So to do that, all I'm going to do is copy these two nodes here, the vector float and the division, and instead of Y divided by X, which is what we had for this first one, we're now going to do X, we're going to do divided by Y, and this is going to go into the X value, and this float, the number 1, the unchanged value, is now going to go into the Y. Plug that into the else statement, and with all that set up, I can go back to the main graph and go to the root level, and now regardless of what I set for the X or Y, the size will always stay that same ratio. In some cases, you might want to be able to make manual size adjustments to the pattern. So we can actually recreate the controls for that. I'm going to create a new parameter and call it size XY. And then I'm going to change the type to float2. just like the original control. Let me actually just copy and paste this node so we can visualize what the size controls in the tile sampler look like originally. I'm going to reset this to default value. So basically we have a size. At 1 is the default. You can go larger, of course, to 2 or something. And then when you go to 0, that is like a size of 0. So it flattens the shape completely. So we're going to try to recreate this control. It's actually pretty simple. I'm going to delete that and go to our previous or tile sampler. You can get back to the function through the function button, or if it's already been opened in the function graph, that'll be in a tab up here. So first thing I want to do is get that float 2 that we just made. Gonna grab that, size XY. Then I actually want to subtract 1, because if this is a value of 1, we don't want to be adding anything to this or subtracting anything from it. We just want it to be a change of 0. So I'm going to hook that 1 and 1 float up to this. So we're subtracting 1 from each float here. And then I'm going to create an add node and hook these together. And by default, nothing should happen when I set that as the output. But if we go back, we should now have this control where we can change our X and Y scaling and, of course, increase them. So basically now you have an exposed control for the size and this autocorrect in the same function. So hopefully this gives a bit of an idea of how functions work, as well as how flexible they can be. If you have any questions or any feedback about anything covered in this video or any designer workflows in general, feel free to hit me up on any of these fine apps. Again, I hope this was helpful, and thanks so much for watching.